In this video, I am going to tell you about some important points regarding the electric flux. In the previous video, already I have discussed that when a closed surface be held in an electric field, then the electric flux passes through that closed surface is given by phi E is equal to whole integration closed A vector E dot vector dA, and this is equal to how much here? E A cos theta. I hope maybe all of you familiar with this relation, and here this means for closed surface here. So this one is for closed surface, and in this way you can find out the electric flux passes through a closed surface when held in an electric field, where E is the electric field, A area of that surface, and theta be the angle between electric field and area vector. Area vector means normal drawn on that surface taking outward. Now I am going to discuss some special case. First case is what here? When surface is held in an electric field, means here if the plane surface is normal to the electric field, in this case, how can we find the electric flux passes through that surface? Dear student, be careful about this one. Here plane surface is normal to the electric field. Then again you remind that example which already I have given, like umbrella one. Suppose this one is simply an umbrella, and in which this one direction of its area vector here, and this one is what here? Electric field, which is just like the raindrop. And in this case you see here this plane surface is this one, surface of the umbrella. This one is a plane surface, and that plane surface is normal in this electric field E. It means this plane surface makes an angle 90 degree with it. But with this electric vector E and area vector A, both makes what angle here? Here theta is equal to 0 degree. It means if the plane surface is normal to the electric field, then its area vector be always parallel to the electric field, and in this case you will take theta is equal to 0 degree, and electric flux passes through that surface phi is equal to E A cos 0, and which is equal to here E into A. Now the second case, if the plane surface is parallel to the electric field, here I am saying plane surface is parallel to the electric field, then in this case what you will take the value of theta. As you know, theta be the angle between electric field and this area vector of that surface which is held in that electric field. Now you see this case here. Again you will take that umbrella like this one, and suppose the umbrella is rotated like this here. Now its surface of this umbrella, you see this surface of the umbrella is parallel to electric field E. It means the plane surface is parallel to the electric field, this plane surface, and which is parallel to the electric field. But this area vector of this umbrella, this one, is makes what angle with this electric field here? 90 degree. It means in this case theta is equal to 90 degree, and electric flux passes through that surface is how much here? E A cos 90, and as you know cos 90 is equal to 0. So in this case electric flux becomes 0. Dear student, please don't confuse in this one. If the plane surface is normal then generally a misconception arises in the student's mind. In normal means 90 degree, but be careful, especially to solve the numerical. If the surface is normal, then theta is equal to 0 degree, and if the surface is parallel to the electric field, then theta is equal to 90 degree. And third case is what? And third case, if the plane surface makes angle theta with the electric field, then in this case the electric flux passes through that surface. Phi is equal to, you can calculate EA cos 90 minus theta. Dear student, by using these formula we can find the electric flux passes through that surface. For example, suppose if the plane surface makes angle 90 degree with the electric field, when theta becomes 90, then 90 minus 90 means this becomes cos 0 degree, which is already first case. And if the plane surface makes angle 0 degree with the electric field, means parallel, then in this case here you will take theta is equal to 0, then phi is equal to EA cos 0, and cos 0 is equal to 1. So simply, if the plane surface makes angle theta with the electric field, then you can find the electric flux through that surface. Phi is equal to EA cos 90 minus theta. Now next topic is electric flux density. Dear student, electric flux density is the ratio of electric flux passes through a surface to area of that surface. And if that surface is normal to the electric field, then you know phi is equal to E into A. So that one comes what here, EA upon A is equal to E. This is called electric flux density. So simply, electric flux density is the ratio of electric flux passes through a surface to magnitude of that area. Dear student, since electric flux is the dot product of vector E and vector A, so you can say the dot product of two vectors is a scalar quantity. So remember this, electric flux is a scalar quantity, And not only electric flux, any type of flux, either electric flux or magnetic flux or gravitational flux, all these are what quantity here? Is scalar quantity. And how can we find the unit of this electric flux? Then you know phi E is equal to E A cos theta, and you know the unit of E, as a unit of E, Newton per coulomb, and area is what here? Meter square, and cos theta, this one is a trigonometrical term, so there is no any SI unit of it. So simply you can say unit of electric flux phi is equal to Newton per coulomb into meter square, or you can write Newton meter square, and this one is a per coulomb. And the dimension of the electric flux, how can we find? As you know, unit of electric flux phi E, Newton per coulomb into meter square. So its dimension you can write here. Dimension for Newton is the unit of force. So dimension M L T minus 2 into meter square means L square upon coulomb. And you know the dimension for this coulomb Q is equal to IT. So its dimension you will write A into T. And finally, when you will transfer this AT in numerator, then you will get here M L into L square is L cube. Here A to the power minus 1. And when you will take this T in numerator, you will get here T to the power minus 3. And in this video, student, you can find out the dimension of the electric flux. So here this topic about the electric flux is over. Please, once all of you go through this electric flux also with the help of your book, and tomorrow I will give you the next video for the Gauss theorem, which is very, very important. Thank you.